Welcome to Inferential Statistics for AI. Everything you see will be built on screen, step by step. Descriptive statistics summarize the data in front of us. Inferential statistics does something harder. It uses a sample to make a claim about a population we never measured. Every accuracy score you report is exactly that kind of claim. The population is every individual of interest. A sample is a subset. Sampling selects it. Inference concludes about the whole. Models train on one sample and evaluate on another. The goal is generalization, performing well on the population, not just the rows the model saw. Random sampling gives every member an equal chance. Stratified sampling splits the population into groups, then samples within each. Cluster sampling picks whole groups at random. The method decides whether results are biased. Hypothesis testing is a 5-step procedure. State H0, the default of no effect. State H1, the claim you seek evidence for. Choose alpha, usually 0.05. Compute the p-value from the data. Finally, reject H0 only when the p-value falls below alpha. A type 1 error rejects a true null, a false positive, at rate alpha. A type 2 error keeps a false null, a false negative. Lowering alpha raises type 2 errors. It is a trade-off, not a free improvement. We never accept the null. We only fail to reject it. It means the evidence was not strong enough to rule the null out. A test on 12 samples fails to reject almost anything. A statement about power, not reality. A model claims 85% accuracy. On 100 samples, it gets 78 right. H0, p equals 0.85. The standard error is the square root of 0.85 times 0.15 over 100, about 0.0357. That gives z of minus 1.9604. The p-value is 0.04995, just below 0.05, so we reject. But had it gotten 79 right, the would be minus 1.68, the p-value 0.093, and the conclusion would flip. A result that turns on one sample is underpowered. A confidence interval gives a range likely to contain the true parameter. For the mean, it is the sample mean plus or minus z times standard deviation over root n. The critical value is 1.645 for 90%, 1.96 for 95, 2.576 for 99. The 95% describes the procedure. Repeated sampling produces intervals of which 95% contain the true mean. 64 evaluation runs give mean accuracy 0.85 and standard deviation 0.08. The standard error is 0.08 over root 64, which is 0.01. The margin of error is 1.96 times 0.01, giving 0.0196. The interval runs from 0.8304 to 0.8696. A single number hides this uncertainty. The interval makes it visible. A spam detector is tested on 1,000 emails. 180 spam caught, 20 missed, 30 wrongly flagged, 770 correct. Accuracy is 95%. Precision is 180 over 210, 85.7%. Recall is 180 over 200, 90%. F1 balances them at 0.878. The model is accurate overall, but precision and recall reveal what the single number hides. That's inferential statistics for AI.